Okay, I am not hearing or seeing actually Steph, but I'm just going to take that as silent approval that we're going to kick off now. Yes, okay, great. That looks great. I'm so happy to see everyone zooming in from so many places, and that you're all as excited as me to welcome Anne Scheel as our speaker to today's reproducibility session. And I thought I will just briefly introduce Anna. I'm sure you already have heard of her or come across her work online, but I just wanted to, I guess, express my fandom a little bit. So Anne is currently a doctoral candidate at the TU Eindhoven and is conducting research in meta-science on increasing reliability and efficiency of psychological science. Before that, she finished a psychology degree at the University of Heidelberg and a research master's at the University of Glasgow. So a very suitable speaker today. And I first actually came across Anne's work when I was listening in the summer of 2017 to the Everything Hurts podcast. I was an intern in a research lab, and I had the most intern job of scanning a massive folder of documents, and I needed to do something in this hours of time that I spent scanning, so I just started listening to Everything Hurts, and one of the first guests that I heard on this podcast was Anne Scheel, and I was extremely impressed with everything that she said, and it really resonated with me. And then I followed her on Twitter, and I would recommend you to do the same. She can be found at Anne M. Scheel. She also hosts the excellent rotating curator account Real Scientist Germany, and she blogs at the 100% CI blog and has published a really cool blog post that I can recommend you to check out as well. So take it away, Anne.
Yeah, hi everybody. Thank you so much for inviting me. This is very exciting, especially like Anna said, since I actually did a master's in Glasgow and lived there for a year, and I'm extremely fond of the place still. So even just being there virtually is very nice, although it's sad to not be able to be there in person. Right, so yeah, without further ado, let's start to talk about this paper. Very recently pre-printed with my colleagues Mitchell Sine and Daniel Atkins. So we're talking about the paper, an excess of positive results, comparing the standard psychology literature with register reports. So I assume that most of you will be familiar with the background of the study, but to give you a brief overview of what motivated us to do this research. So some background here. One thing we know about the psychology literature is that it contains a really large proportion of positive results. Usually that means statistically significant results. And one point where we can see this is the Reproducibility Project Psychology that I guess most of you will be familiar with, a big study that came out in 2015, where researchers took 100 studies from 2008 that were published in 3 big psychology journals and replicated them. And the finding that this study is best known for is that most of these replications failed, in the sense that the most replication outcomes were not significant, where the original studies had to be significant. But what I want to highlight here about this study is that these 100 original studies that they picked to replicate had 97% of those had significant results, the original studies that were published. So almost all of them, almost all 100 studies had a positive result. And the authors didn't select them based on that. They tried to, it wasn't a perfectly random sample, but it also wasn't completely handpicked. What's interesting about that is that this number isn't new at all. There's a much older study that finds a very similar one. You don't have to look at this whole table. So I just want to draw your attention to this box here that I highlighted. This is a study from 1959 by Theodore Sterling, who looked at one yearly issue of 4 big psychology journals of the time, and just counted how many published papers used significance tests. And of those that used significance tests, how many of them were significant and rejected the null hypothesis. And he found that 97%, 97.28% of those did, so also had positive results. So that's quite striking that we have two studies that are almost 60 years apart and find such a similar rate of positive results in literature. And there's another more recent study that was quite impactful by Daniele Fanelli that used a very different method. So Fanelli compared the literatures of 20 different disciplines and just looked at the first hypothesis tested in a paper and whether or not this hypothesis was supported or not. So this wasn't about significant results per se. And he found, and for psychology, he found a positive result rate of 91.5%. So a bit lower than the 97% we've just seen, but still very high. And in particular, higher than all the other disciplines he looked at. And in his paper, he actually makes the claim that there's this hierarchy of sciences from the hard sciences to the soft sciences, and that psychology is all the way down at the bottom of the hierarchy of sciences as the softest science with the most positive, the highest proportion of positive result. There's another paper by Fanelli 2 years later where he looked at a trend over time. This is here on the right, where he claims to have found that there's a positive trend over time, that results have become more positive over time. I'm a bit less sure about that, especially given this Sterling study that I just showed you, where we have 97% positive results already in the 1950s. But nevertheless, the main point here is that we have quite a bit of evidence that the psychology literature is extremely positive, almost perfectly positive, we could say. So over 90% of papers seem to find significant results. And that is a bit odd if we consider one other thing, namely that we have pretty good evidence that statistical power in psychology studies isn't as great as we would like, maybe. So there have been many studies over the years looking at the sample sizes and study designs used in psychology papers, and then calculated how much statistical power these studies had to detect effects of certain sizes. And what has been found is that power has been consistently pretty low, at least for these effect sizes that we can look at. So a recent study looking at papers in neuroscience and psychology, for example, found that on average, power to detect medium effect sizes was less than 50%. And that means that if the effect size is medium size, less than 0.5%, and there is a true effect, then less than half of the studies you run would actually give you a significant result. And even for large effects, power isn't really great. So the combination of these two insights, we have low power in the field. So if there are true effects, then we are not very likely to find them. And at the same time, knowing that we have literature that contains almost exclusively significant results, that's weird, right? So there's something, how do we explain that? So I think there are two possible explanations. The first is that psychologists only test true hypotheses with very large effect sizes. So every hypothesis we have is true. So all we can do is have a few false negatives. And then all the effects that we study are also really large. So even with our small samples, we have really, really good power. That might not be the most plausible explanation. Maybe more plausible is that there are negative results, but we don't see them. So we have bias in the literature, and that can come from several sources. One is file drawing, meaning you get a negative result, but it doesn't end up in the literature, either because you choose to not submit it for publication, so you put it in your file drawer, your metaphorical one or your physical one, or the Dropbox folder, as my supervisor likes to say, the Dropbox folder that you stopped syncing 5 years ago. Or you maybe try to submit these results for publication, but they get rejected because reviewers say they aren't interesting. Another possible factor is p-hacking. So you get a negative result and you don't like it, and then you play around with it until it becomes significant through some means of magic. Other questionable research practices like hypothesizing after results are known. And then there's also the possibility that you are actually trying to be completely honest, but then reviewers and editors are sort of pushing you to use questionable research practices and display your results in a more positive light. And any of these things might lead to negative results sort of disappearing from the literature, even though they actually exist. So one reform that's been suggested to fix this, that also most of you will be familiar with, is the registered reports format. And just to quickly recap, in registered reports, what happens is that before you actually run a study, before you collect the data and analyze the data, you write up your hypotheses and method, you submit that to a journal for review, where it gets reviewed. So this is here, develop idea design stage. And in this stage of peer review, if reviewers are happy with what you're suggesting, say, yes, this is a good research idea, this is a good way of studying it, the journal will grant you an in-principle acceptance, meaning that they will say, you can now go collect and analyze your data, and regardless of what you find, we will publish the final study. Now you can go collect your data, analyze your data, write up the final paper. There's a second stage of review, but this time only to check if you really did things as you said you would. So your paper can still get rejected, but only if you really screwed up and did things that were, if the study really didn't work at all, but not because the results were negative. And so the advantage of this system is that, one, it is a type of pre-registration, meaning that you publicly state your hypotheses and the way you will test them before you know the results. And the publication decision is made before the results are known. So, so that means we have a reduction of questionable research practices on the side of the researcher, and we reduce publication bias because negative results can't be suppressed anymore. I mean, researchers could still decide to withdraw their paper, for example, if they get a negative result, but that seems a bit unlikely because they have a guaranteed publication at this point. Registered reports were launched in 2013. They're now offered by over 200 journals. And we now have quite a mass of registered reports that have been published. So that's been finalized with the data. And so given that this looks like a really interesting and powerful system to contain bias against negative results, I've been interested in whether registered reports work. If we can tell that, given that we should expect that they make it easier to publish negative results, do we really see that registered reports have more negative results? So this brings us to our study. And we wanted to compare the proportion of positive results in the standard literature with registered reports, and restricted to psychology because that's my field of expertise. So what we did is we used the method by the same method as Daniele Fanelli in the study that I showed you earlier, because it's very easy to use. So what Fanelli did was he searched the literature, he searched journals for the phrase test the hypothesis to only include hypothesis testing papers. And this is how we sampled the standard reports in our sample. For the registered reports, we did not use this criterion. We just took a database of registered reports and included all of them that tested the hypothesis, regardless of whether or not they used this particular phrase. And then for all the papers in both groups, we extracted the first hypothesis. And then we coded if that hypothesis was supported or not. And to do that, we went by authors' verbal statements. So we did not analyze p-values unless authors' verbal statements just didn't really contain a conclusion. So we basically just go by what authors say about whether they found their hypothesis was supported or not. And this is, I mean, we can talk about the limitations of this approach, but it's fairly quick, and I think it has some face validity at least. Just to very quickly show you the two samples we had, you don't need to dive through this whole diagram, but we have the sample of standard reports So we searched psychology journals for this phrase, test the hypothesis, and then we sampled 150 papers of those. We oversampled slightly in the end because of some replacements. We excluded papers that did not test the hypothesis and that we couldn't code. And for the registered reports on this side, we went by a public database, excluded all papers that were not in psychology, excluded papers that were actually not registered reports so that we couldn't verify registered reports. And again, if they didn't test the hypothesis or we couldn't code them. And then we ended up with 71 registered reports. So we have these two samples that we compared. And now the results that you've probably seen if you've looked at the paper already or looked at my Twitter page. What we find, again, interestingly, for the registered reports, positive result rate of 96%. So this is very similar to the numbers that I've shown you earlier, which I find really interesting that it's so close to, here as a reminder, the 97% in the reproducibility project and by Sterling. But the registered reports, on the other hand, were less than half as positive as that. Way, way, way more negative results in the registered reports. And that is really quite striking. I'm not sure what I did expect. I definitely expected a big difference, but this is still quite impressive to see for me. So of course the difference is significant. Right, so if nobody has any questions at this point, I'm just going to go on to some. So this was sort of the main analysis of our main hypothesis. We then also looked at whether there was a difference between papers that were replication studies and that were not. And the reasoning behind that is that, so the registered reports literature that has been papers that have been published so far, many of those we know are direct replications of earlier studies. And that's probably because at the same time as registered reports became popular, there's been this movement of we need to replicate studies more. And we want to do that very thoroughly. So we use the registered reports format to do that. And with these direct replications, it's possible that the reason people run them is that they are skeptical about the original result. So they say, I don't believe this result, I'm going to replicate it and show that it's not real, for example. And if that is true, then it could be that in this registered report sample, we have a lot of failed replications. So we have a lot of papers that had a very low probability or any hypotheses with a low prior probability because people selected them based on this low probability of being true. And that could be a confound because we know that replications are rare in the normal literature. So that's why we also tried to code if a study was a direct replication of previous work or not. And then we split the sample, looked at that. And this is what I show you on the next slide. So here we split our sample in what we call original studies and replication studies. Important to note that we only counted direct replications as replication studies, so not conceptual replications, and also not internal replications where you replicate a study that is published in the same paper. And as you can see, replication studies were very common among the registered reports. So more than half of the registered reports were direct replications, as we kind of expected, and only 30 were not. But in the standard reports, only 4 of them were direct replications, so extremely rare. But you can see that the general pattern that we saw before holds in the original studies alone. So this difference in positive results between standard and registered reports is still significant for if we only look at original studies. And then in the replication studies, it's very difficult to say anything because there are only 4 standard reports. And I mean, they are all positive, which I find kind of funny because this is the opposite of what we would expect for sort of skeptical replications. Yeah, but it's just 4 papers. So who knows what's really going on.
Hey, Anna,
Yeah.
Sorry to interrupt you, but I think we just have a question from Lisa.
Yeah.
If you want to comment on that.
Yeah, sorry. I'm just trying to read through it now. So I'm to read it to everybody. While recommending registered reports to colleagues, I got the feedback that they would not like to publish with it, since it might look like you have expected null results at the beginning of your study, meaning that you did not have faith in your study, because registered reports are the only format where you can successfully publish them. This would, they say, lead to a negative resonance to the study. How would you counter such arguments? That's a really interesting question. That's actually part of my discussion. Basically, so I'm gonna go back a slide. So basically what we did in the study was just a descriptive analysis, right? So we can't really say anything about causality. Like we can't, it's not an experiment. We didn't experimentally tell people to use the registered report format or not, and then looked at what happens. So it's possible that there are confounds here that led to this result. And one of these confounds that I could think of is that people use registered reports strategically for unlikely hypotheses, right? For exactly this reason. So people want publications. There's publication bias, so we know negative results are difficult to publish. So if you have a very unlikely hypothesis, you might be reluctant to do it in a normal study because you might get a negative result and then you can't publish that. But you can publish it in a registered report. So you might say, I'm only gonna go to the troubles of running a registered report for my unlikely hypotheses because I'm guaranteed to get a publication with them. And I'm not sure how, I wouldn't expect that that's very widespread behavior at this point, but it might play some role. And it's really interesting in this light to see this comment that actually some people apparently have the concern that registered reports are sort of used exclusively for sort of unlikely hypotheses in the first place. So where I don't really understand why that would be a problem is that I think hypothesis tests should sort of be judged on the value of the hypothesis being tested rather than the result, right? So in the sense that, is the hypothesis interesting to test? And if it is, then we want to test it in a very stringent way. So basically, you could say that if you look at the general literature and we have more than 90% positive results always, if that would happen without any bias, it would mean that we basically only test through hypothesis, and we have such a high prior that we already know that the hypothesis is true before we test it. And you could say that we only test trivial effects. It's not interesting to test them. We already know that they are true. Right? So to me, that is actually more damning than testing a hypothesis with a low prior. And you could say that testing hypotheses that are very unlikely are actually more interesting in many cases, at least if they are, for example, predicted by just one theory that you think might be true, and they would be very unlikely to be true in other cases. So yeah, I'm not sure how to sort of counter the argument to registered report skeptics. At this point, I have to think about it a bit more. Yeah, maybe we can move the further discussion of this to sort of Q&A. You know, just gonna go on for a little bit. If that's okay? Okay. Yeah, so I'm gonna, very, very briefly. So another aspect of our paper was to look at the language that was used to introduce a hypothesis, to describe a hypothesis in a paper. And that's because our standard reports were all selected on whether they contain this phrase, test the hypothesis. That's how we sample them, but not the registered reports. For the registered reports, they could use any language, and that could be a confound, right? So therefore, we also looked at what language registered reports used to describe the hypotheses. And only 2 registered reports in our sample had contained this phrase. And what we found was that the most common word stems that were used to describe a hypothesis were hypotheses. So this could be a noun, hypothesis, hypotheses, but also hypothesize as a verb. Replicate, so this is here, you can already see that replications were extremely common. This was one of the most common word stems. And that was actually interesting because we found that replications were usually described in a different language. So people phrased this less as a hypothesis test than as repeating something that was done before. So we replicated this, or we tried to replicate the effect, or we replicated this method rather than we tested the same thing. So I thought that was interesting. Then we also had test, examine, and predict as very common words. So most of the registered reports would have been found if we had used these search terms in a literature search, because they have these phrases in the abstracts and titles already. Not sure how well this generalizes to the general literature, but I think this is can be useful if we want to use the Finelli method in the future, because test the hypothesis is very specific, and as we can see, almost none of the registered reports use them, so we don't really know what this phrase gets us. Yeah, I'm going to skip over these. These were just a few examples of described hypotheses. So briefly, as a conclusion, we find that registered reports have dramatically fewer positive results than standard reports. As I already said, we can't really be sure what drives this effect because it wasn't an experiment. So for example, registered reports authors could be different people than the people who don't run registered reports. And I think that's actually quite likely, especially in the early days, where like early adopters of registered reports might be very idealistic people who have very different ways of doing science than people who wouldn't use the format. And this might play less of a role as the format becomes more popular. And as already just discussed, registered reports might be used strategically for very unlikely hypotheses because you're guaranteed a publication. And if you don't use a registered report, you might not be able to publish your study. And there are some other potential confounds. But one thing that I think is absolutely clear is that the standard reports have way too many positive results. So 96% is just too high. You can't explain that with statistical, given assumptions about statistical power and prior probability of hypotheses. So there must be something else. This is just too much. So next steps for myself, my own research is a lot of focused on zooming in on these alternative explanations or things that might be different between registered reports and normal papers. So for example, the prior probability of the hypothesis tested in these different formats. And not necessarily just to try to explain the difference, but also because I think the format might really change how people do research in a fundamental way. And I'm just very interested in how that works. Yeah, so that's the presentation to this point. So happy to take more questions or to collectively think about the problem we encountered earlier about convincing people that registered reports might be worth it despite having negative results.